Velocity data in SegWi format can be loaded using the Insight SegWi Loader, as you would load a normal seismic volume. Just remember to set the class to velocity during loading so that it is recognized as velocity by Insight. A lot of velocity data comes in ASCII format, which must be loaded using the ASCII Loader in the main DUG Insight import menu. In this short tutorial, we will review the steps for importing ASCII velocity in VELF format. Although the VELF format has a standard definition, there are many varieties of VELF that have evolved over the years, so let's take a look at the main features before we start loading. Here are examples of both 2D and 3D VELF formatted files. I will open one of each. VELF is ASCII, which means it can be opened in any text editor and easily reviewed. This 3D VELF file has no headers, but many VELF files will have a header data which is useful to understand the history of the file, but is ignored during import. There are two main keywords. The keyword SPNT marks the inline crossline location for the velocity trace. The keyword VELF marks the pairs of Z and velocity which are read across multiple columns and rows. The Z value could be time or depth. The velocity is most likely to be RMS, but could also be average or instantaneous velocity. Any other values in the file are not required by Insight and ignored during import, such as this repeated crossline location at the beginning of the VELF pairs. This 2D VELF format has a new keyword for the line name. This keyword is not currently used by Insight as the line name is taken from the file name, and each file must contain data for a single 2D line. The SPNT keyword is used by Insight, but in the 2D case the SPNT represents the CMP value. If the VELF file SPNT value is a shot point, this must be converted to a CMP value before loading. The VELF keyword marks the pairs of Z and velocity which are read across multiple columns and rows, as they were with the 3D example. VELF formats will vary, but to be considered VELF, they should have the general features described of two keywords and pairs of Z velocity points. Once you understand the format of your VELF file, select the Import Volumes ASCII Volumes menu. The ASCII volume loader is very similar to the SegWi Loader wizard. Simply complete each window of the wizard and click Next to progress through to the end. Let's start with the 3D volume, which is time velocity data stored in VELF format. Most 3D velocity data comes in a single file, but it is possible to select a single volume spread over multiple files if necessary. Select the location keyword that matches the keyword stored in your file. The default value is SPNT, but a common alternative is VELF SP. Other alternatives exist, and so there is a custom keyword option provided for these cases. Select the inline and crossline values. Note that VELF format often has crossline first, then inline, but in this case it is the reverse. Always check the inline and crossline values against the expected range of values to confirm the correct selection. Select the data keyword that matches the keyword stored in your file. The default value is VELF, but common alternatives are IVEF and VEF. Other alternatives exist, and so there's a custom keyword option provided for these cases. Type in the column number for the first Z value on the first row of Z velocity pairs. Note there is an unused crossline value in this file, which needs to be ignored, so the first column is 3. The data is highlighted in blue, confirming the selection. Type in the column number for the first Z value in the second row of Z velocity pairs. Note the crossline value is missing on the second line, so the first column is 2. All further rows for this location are expected to be the same. Run the analysis for the wizard to understand the size of the file and to check for any potential problems. The orange text is just a warning and helps to understand if any changes are required. Blue text is good and means everything is okay. Red text is an error and means you need to go back and check your data and settings. The warnings here relate to this final sample increment and can safely be ignored. The survey for this example already exists and is automatically selected here. If this was the first volume to be imported, a new survey would need to be created or imported before proceeding. Finally, set the volume name. In this example, I will copy the file name which captured the PSTM origin of the velocity, as well as the RMS velocity type. The name is useful to the interpreter, but it is the class that is recognized by the software for process calculations. Set the class to the correct velocity type, in this case RMS. Done. Importing 2D VELF is very similar, with a few notable changes, so let's run through that now. After selecting Import Volumes ASCII, select the 2D time velocity model in VELF format. A 2D VELF volume must be stored as separate lines. One file is one line. This velocity data exists for 5 2D lines, and so there are 5 files to select. The 2D line name is taken from the file name and not from any keywords inside the file. The file names in this example are a combination of the line name and the data type, and do not match the line names already loaded to Insight. The line names can be manually edited to match the lines in Insight, or, as in this case, you can strip the suffix leaving just the line name. In this example, the default SPNT keyword for the location matches the data and so does not need to be changed to a different value. Insight is expecting a CMP value for this location. Check your data to make sure this is a CMP value in the file and not a shot point value. Shot point values will need to be manually converted to CMP values before import if this is the case. The default VELF keyword for the Z velocity pairs matches the data and so does not need to be changed to a different value. The first column after the VELF keyword is the first Z value, which is the second column in the file when including the VELF keyword. The second row is the same, and so input column 2 for both data columns. The data is highlighted in blue, confirming the selections. Run the analysis for the wizard to understand the size of the files and to check for any potential problems. The blue text here is good, it means everything is okay. The orange highlight seen here is just a warning and helps to understand if any changes are required. Hovering on the highlight provides more information on the warning, which in this case shows some of the files have an irregular CMP spacing or time interval. If the survey does not exist, you can create or import it here. In this project, the survey already exists and is selected. However, only 5 lines are being imported, which are listed at the bottom of the line list. The green text confirms that the line names have been matched and that the CMP range is valid. Finally, set the volume name. In this example, I will copy the file name which captures the PSTM origin of the velocity as well as the RMS velocity type. The name is useful to the interpreter, but it is the class that is recognized by the software for process calculations. Set the class to the correct velocity type, in this case RMS. Done. Always QC your data after import. Viewing the data in the original format is a start. There are some color bars in Insight which will reveal subtle changes. RMS velocity has a gradual increase with depth and is unlikely to reveal any problem values. Use the velocity conversion process to convert to interval velocity for a more detailed QC. This smoothly varying interval velocity looks great. There's a lot more detail in this case, including the high velocity layers towards the top of the section.
If you have questions or would like to discover more, then visit our website at www.doug.com. And remember, have fun with Insight.